Hi, I am Hemapalan from AROA. My topic is Hall effect sensor. What is a Hall effect? The Hall effect is the production of a voltage difference across an electrical conductor transfers to an electric current in a conductor and to an applied magnetic field perpendicular to the current. It was discovered by Edwin Hall in 1879. For clarity, the original effect is sometimes called the ordinary Hall effect to distinguish it from other Hall effects which have different physical mechanisms. The Hall coefficient is defined as the ratio of the induced electric field to the product of the current density and the applied magnetic field. Hall effect sensor. Hall effect sensor is a transducer that varies its output voltage in response to a magnetic field. Hall effect sensors are used for proximity switching, positioning, speed detection, and current sensing application. Working principle. Hall effect sensor consists basically of a thin piece of rectangular p-type semiconductor material such as gallium, indium antimonazite, or indium arsenide passing a continuous current through itself. When a device is placed within a magnetic field, the magnetic flux line exerts a force on the semiconductor material which deflects the charge carries electron and holes to either side of a semiconductor slab. This movement of charge carries is a result of a magnetic force they experience passing through the semiconductor material. As these electrons and holes move sideways, a potential difference is then the movement of an electron through the semiconductor material is affected by the presence of electrical field which is at a right angle to it, and this effect is greater in a flat rectangular shaped material. The effect of generating a measurable voltage by using a magnetic field is called Hall effect, after Edwin Hall, who discovered it back in the 1870s with the basic physical principle underlying the Hall effect being Lorentz force. To generate a potential difference across the device, the magnetic flux line must be perpendicular to the flow of current and be of a current polarity, generally a south pole. A Hall effect provides information regarding the type of magnetic pole and magnitude of the magnetic field. For example, a south pole would cause the device to produce a voltage output, while a north pole would have no effect. Generally, all effect sensors and switches are designed to be in the off. Hall effect sensors are available with either linear or digital outputs. The output signal for a linear sensor is taken directly from the output of a operational amplifier, with the output voltage being directly proportional to the magnetic field passing through the Hall sensor. This output Hall voltage is given as VH is equal to RH into I by T into B, where VH is the Hall voltage in volts, RH is the Hall effect coefficient, I is the current flow through the sensor in amps, T is the thickness of the sensor in mm, B is the magnetic flux density in Teslas. Hall effect applications. Hall effect sensors are activated by a magnetic field, and in many applications the device can be operated by a single permanent magnet attached attached to a moving shaft or device. There are many different types of magnet moment, such as head-on, sideways, push-pull, or push-push, etc. sensing moments, which every type of configuration is used to ensure maximum sensitivity. The magnetic lines of flux must always be perpendicular to the sensing areas of a device and must be correct polarity. Also, to ensure linearity, high field strength magnets are required that produce a large change in field strength for the required moment. There are several possible paths of motion for detecting a magnetic field, and below are two of the more common sensing configuration using a single magnet: head-on detection and sideways detection. Advantage of Hall effect. Production of output voltage signals independent of the rate of the detected field. All of its sensors are not affected by ambient condition such as dust, humidity, and vibrations, and are due to or insensitive to some ambient condition based on a principle that these sensors display a constant flow of electrical current, making their characteristics constant over time. All of the sensors do not have a contact with neighboring mechanical parts, making these sensors strong and sensitive enough to detect movements. These sensors do not wear over time, thus maintain quality and unlimited use. All of its sensors are built from semiconductor material that display low carrier density, hence conductivity is smaller and their voltage is larger. All of its sensor depends on carrier mobility, which eliminates any perturbations due to surface elements, thus making these conductors reproducible and highly reliable. Disadvantage of Hall effect. Hall effect sensor is not capable of measuring a current flow at a distance greater than a 10 centimeter. However, use of a magnet strong enough to generate a magnetic field wide enough may make this possible. All of its sensors work on a principle of a magnetic field, making it possible for a external magnetic field to interfere with this and bias the measurement of a current flow. Temperature affects the electrical resistance of a element and the mobility of a majority carrier and also the sensitivity of a all of its sensor. Even with the well-centered electrodes, the offset voltage is still represents as an output voltage in the absence of magnetic field. An offset voltage occurs when there are physical inaccuracies and material non-uniformity. It can be as high as 100 MV for a 12 volt source. Application of Hall effect sensor. Hall effect sensor is considered as a magnetic sensor with a wide range of application. Some of the most popular and effective way of utilizing Hall effect sensing devices are listed below for both analog and digital output sensor. Analog output sensor application includes current sensing, variable speed drives, motor control protection or indicator, power supply sensing, motion sensing, flow meters, direct current electricity encoder switches, rotary encoders. Digital output sensors applications includes wireless communication, pressure sensor, proximity sensor, flow sensor, valley position sensors, lens position sensors, shaft position sensor. Summary is Hall effect sensor were developed in 1950 and have come a long way to become a major requirement for several industrial and automotive application. Thank you.